No?
It's on the whiteboard.
Oh, it's a whiteboard. Keep the lights on, yes.
I'm sorry.
Once again, I take you to the classroom teaching old-fashioned one.
Okay, next
And
one.
I apologize for being old-fashioned, but I hope I would communicate my ideas very precisely and correctly and accurately.
Okay. Please go ahead, Daya.
Okay, so
Role of light front zero modes in string theory.
yes, so I try to emphasize in this talk the extremely positive role played by the light from zero modes in string theory. I would try to speak more in words than in mathematics. So there is twofold purpose of my talk. One is to highlight that without the light from zero modes, you cannot obtain the mass spectrum of the string theory. And then the whole purpose of constructing the beautiful alternative theory or a candidate theory of quantum gravity would be lost if you cannot generate the mass spectrum of the theory. And I will show to you that zero modes play a very crucial, vital role in the construction of the mass spectrum of the theory. This is one point. Another point is about the compactification of the so-called extra dimensions in string theory. As we know, the critical dimensions of string theory for a bosonic string theory is 26, and for a superstring theory it is 10. But we live in a four-dimensional world, and we prefer to live in a four-dimensional world and not in a 10 or a 26-dimensional world. So obviously we would like to compactify the so-called extra dimensions and get back to the four-dimensional world in which we live. So that is the idea. And here, this also cannot be achieved without the light from zero modes of the string theory. So these are the 2 points which I would like to highlight. I try to do it in the given time. So let me avoid writing the Polyakov action. We all know it's a very famous Polyakov action for bosonic string theory. And if you write it, but okay, as is so this is the conformally gauge fixed Polyakov action, and you can write it as your del plus x mu, del minus x mu times the tension, string tension, and so on. All right, and the equation of motion for this is this, which implies thanks for reminding me. So that is the equation of motion for these string coordinates x mu. X mu are a function of sigma alpha. So x mu sigma plus, sigma minus, or x mu of tau and sigma. There your sigma plus minus is so now with this given correspondence for the light front coordinates, these are the worldsheet coordinates, and these are the coordinates of in the space-time manifold. Now, okay, so the x mu, this is the solution of a wave equation. I can split it into 2 parts, one moving to the left and one moving to the right. So this one of them depends only and only on sigma plus, and the other one depends only on sigma minus. So this is clearly the left moving part, and this is the right moving part. I stick just for illustration purposes to the bosonic string theory. Now, and you can expand it in terms of the center of mass coordinates, x mu plus and the much advertised universal slope by Sternbrodsky. So that is your alpha prime. It remains still same universal slope. We do not touch it any more. So this plus and similarly you write one for the x mu r. where you have it here minus sigma minus, and here you have, so the alpha mu n and beta mu n are the Fourier modes of this x mu. Now this theory has t plus plus equal to 0 and t minus minus equal to 0. T plus plus h, the plus plus component of the energy momentum tensor, and this h x plus x mu whole square. One can again expand the Fourier expansion of this Lm and t minus minus also can be written as, so here these summations over m go from minus infinity to minus 1, then to 0, then plus 1 up to plus infinity. So n equal to 0 is included in this. These are the Fourier modes of t plus plus, these are, and they are called as the Virasoro operators. And what happens actually is that these these commutation relations for the creation and annihilation operators, these are actually equal to alpha nu minus n, and this is alpha nu n. So if you take for 0, 0, then because of the choice of the metric that eta mu nu is minus 1 plus 1, etc. So you have the existence of negative norm states in the theory, and you would like to avoid them. So what one does is you impose a Gupta-Broiler kind of a quantization condition on this, and you demand that Lm minus A, so which actually means you take the expectation value of this and it should vanish. So this is just perfectly analogous to the Gupta-Broiler quantization condition. And in particular, this here, there is a term sitting delta n0, which means psi equal to 0. Now this L0 is the corresponds to the 0 mode, and this A is the normal ordering constant, which is deeply related with the and so when A goes to 1, D becomes 26. For the bosonic sector, for the string superstring theory, there are two choices. AR goes to 0 and ANS, which is the Nebuchadnezzar sector, this goes to 1/2, and both of them are consistent with D equal to 10. So that is the now what happens. So I cannot go into this. This is rather deep derivation for this. So the point is, you essentially have L0, and L0 you can see is 1/2 alpha 0 square plus n, and if you write L0 minus A, so there is minus A. Now in the open string theory, alpha 0 and beta 0 are identically the same, alpha 0 square, beta 0 square, so there is 1n. However, for closed string theory, you have 1/2 alpha 0 square plus nl minus r, and L0 bar minus A, this equal to 1/2 beta 0 square plus nr minus A. So this actually now 1/2 alpha 0 square is actually alpha prime by 4 times p mu, and this, if it is L or R, and this is equal to minus m square. So you put everything back here and apply it to psi equal to 0, you can construct the mass spectrum of the theory. And here, let me not write more mathematical steps, but one can read off from there that this will For the ground state, in open string theory, there is only one n. This is for the closed string theory, n, l, and n are. So this n, when n is 0, a is 1, you will realize that the mass spectrum, you replace this by this, equal to minus alpha prime by 4 into n square, and then you find that the ground state is a tachyonic state. The mass operator is negative mass square term. And the same thing happens also for the closed string theory. Again, the ground state is a tachyonic state. However, for n equal to 1, which is the first excited state here, how you construct these higher energy states is just the same procedure. So you calculate alpha I minus 1 on 0, that would be your first excited state in the open string theory, and this would correspond to a photon. This would be analogous to a photon. So this I would have value 0, 1, 2, etc. up to 24. So there would be 24 transverse components of this state, just analogous to the 4-dimensional electrodynamics, where you have 2 transverse components of the electromagnetic field. However, if you do it for closed string theory, alpha mu minus 1, then here you can have an this would be the first excited state. First excited state, as you can see, is a tensor state. I can split it into symmetric, antisymmetric, and the trace part. Trace part would correspond to the dilaton, symmetry part would correspond to